Picture this. You're standing on a beach at sunset. The waves are crashing. The sky is turning purple. And then you see it. Rising over the horizon is not our familiar moon, but a massive orange orb covered in methane lakes, so close you can see clouds swirling in his atmosphere. Your heart stops, because you know what's coming next. In 6 hours, when the tide comes in, your city will be underwater. This is your new reality. This is what happens when we swap Earth's moon with the alien worlds orbiting distant planets. And I'm about to show you 12 scenarios that will blow your mind. Some will freeze you solid. Some will rip the planet apart. And one, just one, might actually save humanity. Let's find out which. Starting with the gentle giant, Titan, Saturn's largest moon, the only moon in our solar system with a real atmosphere. Swap it in, and the first thing you notice is the color. Our nights don't go dark anymore. They glow. A deep, hazy orange bathes everything in this eerie twilight. It's beautiful, haunting. Like the world is perpetually on fire but never burning. Titan is 50% larger than our moon, so it dominates the sky. You can't look up without seeing it. This fuzzy sphere wrapped in nitrogen clouds, 600 kilometers thick. It looks alive, breathing. And in a way, it is. But here's where things get interesting. Titan is 80% more massive than our moon. More mass means more gravity. More gravity means stronger tidal pull. Suddenly, the oceans aren't behaving the way they used to. High tide doesn't just come in, it devours. Coastal cities from New York to Mumbai are flooding twice a day, every single day. We're not talking about water lapping at the streets. We're talking about waves crashing through 10th floor windows. Entire neighborhoods vanishing under the surf. Insurance companies collapse overnight. Billions of people are displaced. And this isn't a one-time disaster. This is the new normal, forever. Meanwhile, Titan itself is transforming. For billions of years, it's been frozen solid out near Saturn, where sunlight is weak and distant. But now it's here, orbiting Earth, bathing in the full intensity of our sun. The methane lakes start to boil. The icy crust begins to crack. And beneath all that ice is an ocean. A real liquid water ocean, possibly hundreds of kilometers deep. Scientists have suspected it for years, but now we get to see it. As Titan melts, we watch in real time as this alien moon reveals its secrets. If there's life down there, swimming in those dark waters, we're about to meet it. We could land on Titan's surface, drill through the slush, send submarines into an ocean that's never seen sunlight. The discovery of extraterrestrial life wouldn't happen on some distant exoplanet. It would happen right above our heads. But nothing lasts forever. Titan's gravity is too weak to hold on to all that water and atmosphere. Over millions of years, it bleeds into space. The oceans evaporate, the clouds dissipate, and eventually, what was once this magnificent living world becomes just another dead rock circling Earth, a graveyard moon. A reminder of what we briefly had and lost. Now let's go bigger. Ganymede, Jupiter's king of moons, the largest moon in the entire solar system, bigger than the planet Mercury, the only moon with its own magnetic field. Swap this monster in, and immediately you notice the brightness. Ganymede is covered in ice, thick ancient ice that reflects sunlight like a cosmic mirror. Our nights become so bright you can read a book outside without a flashlight. Astronomers are furious because they can't see distant galaxies anymore. This moon is washing out the stars. You need blackout curtains just to sleep. Some people start wearing sunglasses at night. It's that intense. But the real terror is the tides. Ganymede is twice as massive as our moon. The oceanic tides don't just increase. They become apocalyptic. Megatides, waves so powerful they reshape coastlines overnight. Every 12 hours, the ocean rises and falls by such extreme amounts that entire continental shelves are exposed and then submerged. Ports are destroyed. Ships are crushed. The fishing industry dies. But it's not just the oceans. Ganymede's gravity pulls on Earth's crust itself. The ground beneath your feet starts to shift. Earthquakes rip through cities that haven't felt a tremor in centuries. Volcanoes that have been dormant for millennia suddenly erupt. Yellowstone wakes up. Mount Fuji explodes. The Ring of Fire becomes a ring of hell. Billions die in the first year alone. But here's the twist. If humanity survives, and that's a big if, Ganymede actually stabilizes Earth's axial tilt. For millions of years, our planet has wobbled. That wobble gives us ice ages, unpredictable climate shifts. But with Ganymede's massive gravitational anchor, Earth locks in. The wobble stops. The climate stabilizes. No more ice ages. Ever. We get predictable seasons for the rest of Earth's existence. That's the silver lining. If you can survive the initial apocalypse, you inherit a more stable planet. And Ganymede itself becomes paradise. As it warms up in Earth's orbit, that 150-kilometer thick ice crust starts to melt. Oceans form. Water vapor creates clouds. Within a few centuries, Ganymede has weather, rain, maybe even primitive life emerging in those newborn seeds. And because Ganymede has a magnetic field, it can hold on to an atmosphere. It becomes a second Earth, a backup planet. Humanity could colonize it, build cities on its surface, and at night from Ganymede, you'd look up and see Earth hanging in the sky. This blue marble surrounded by auroras from Ganymede's magnetic field interacting with Earth's. Two worlds, locked in a dance, both habitable, both beautiful, both deadly. Next up, the volcano moon, Io. Jupiter's third largest satellite and the most hellish place in the solar system. 400 active volcanoes. Lava lakes of molten sulfur, eruptions blasting material 300 kilometers into space. Io makes Earth's volcanoes look like birthday candles. This moon is tortured, stretched and squeezed by Jupiter's gravity and the gravitational tug-of-war with Europa and Ganymede. The friction generates so much heat that Io's surface is constantly melting, erupting, reshaping itself. It's a world on fire. Swap it in, and the spectacle is immediate. At night, Io glows, not from reflected sunlight, but from its own internal heat. You can see the volcanoes erupting with your naked eye, bright orange and red plumes arcing across its surface. With a basic telescope, you can watch lava flows in real time. It's mesmerizing, terrifying, like having a front row seat to hell itself. But here's the surprise. Io doesn't destroy Earth. It's almost the same size and mass as our moon. The tides barely change. And without Jupiter and its moons constantly ripping Io apart, the gravitational torture stops. The volcanoes quiet down. The lava cools. Within a few thousand years, Io becomes cold and dormant. Just another dead moon. The fireworks are temporary. Enjoy them while they last, because once they're gone, you're left with a dark, silent rock. No better than the moon we already have. Now Europa, the Ice Queen, Jupiter's fourth largest moon and possibly the most important body in the solar system for astrobiology. Beneath its fractured, icy shell is an ocean. A real ocean of liquid water, possibly 150 kilometers deep. More water than all of Earth's oceans combined. And where there's water, there might be life. Scientists have been obsessed with Europa for decades. It's the holy grail of planetary science. Swap it in, and suddenly, we don't need to send a probe 800 million kilometers to study it. Europa is right here, 3 days away by rocket. We could land missions within months, drill through the ice, send submarines into that alien ocean, and the ice is already cracking. Europa's surface is covered in these massive reddish-brown streaks called lineae. Scientists think they're caused by subsurface water pushing up through the cracks and freezing. It's like the moon is bleeding. Now orbiting Earth, warmed by our sun, those cracks widen. Geysers of water vapor start erupting. The ice shell thins, and within a few years, we could actually see the ocean. Touch it, taste it, search it for life. The tides on Earth drop because Europa is less massive than our moon. That's actually a relief after the nightmares of Ganymede and Titan. But over millions of years, Europa's weaker gravity destabilizes Earth's tilt. We start wobbling again. Ice ages return with a vengeance, extreme climate swings. But in the short term, the benefits outweigh the costs. Europa becomes humanity's greatest scientific achievement. We find life, not bacteria, not microbes, but something larger, something that's been evolving in that dark ocean for billions of years, creatures that have never seen light. And when we bring them up, when we study them, we realize we're not alone. We never were. Then there's Triton, Neptune's largest moon and the weirdest one in the solar system. It orbits backward, retrograde. Every other major moon orbits in the same direction as its planet's rotation, but not Triton. It's going the wrong way. Scientists think Neptune captured it from the Kuiper belt. It's not supposed to be there. And if we swap it in, keeping its retrograde orbit, we get a moon that rises in the west and sets in the east. Everything feels wrong, disorienting. Like the universe is broken. Triton is bright. Incredibly reflective ice makes it shine like a beacon. But it's less massive than our moon, so tides drop. The sun becomes the primary driver of ocean tides, and solar tides are weak. Coastal ecosystems start to collapse. Marine life that depends on strong tide can't survive. Fisheries fail. But the real show is the ice volcanoes, cryovolcanoes. Triton erupts frozen nitrogen, water, and methane 8 kilometers into space. At night, you can watch these icy geysers blasting off the surface, glittering in the sunlight like frozen fireworks. It's surreal, beautiful. And as Triton warms up, the eruptions intensify. The frozen nitrogen vaporizes, creating a thick, hazy atmosphere. Triton starts to look like early Earth, cloudy, dynamic, alive. But it doesn't last. The atmosphere bleeds away, the ice melts. And within a few centuries, Triton is just another barren rock. Its retrograde orbit also causes problems. It's slowly spiraling inward. In a few million years, it crashes into Earth. Extinction event, again. We really can't catch a break with these moons. Now let's go tiny. Phobos and Deimos. Mars is two pathetic excuses for moons. They're not even round. Phobos is 27 kilometers wide at its widest point. Deimos is 15. They're basically asteroids. Lumpy, cratered space potatoes. Swap them in, and the night sky goes black. There's nothing up there. Just two faint dots that look like stars. You can't even tell they're moons without a telescope. Moonlight disappears. Nocturnal animals go insane. Predators can't hunt. Prey can't hide. Ecosystems collapse. And the tides. Oh, the tides. They're gone. Almost entirely solar-driven now, which is barely anything. The oceans become stagnant. Coastal wetlands dry up. Marine life dies off in droves. But the worst part is Earth's tilt. Without a massive moon to stabilize it, Earth starts to wobble wildly. The poles drift. Seasons become unpredictable. One century, the North Pole is at the equator. The next, it's back where it started. Ice ages come and go every few thousand years. Agriculture becomes impossible. Civilization collapses. And then, in 50 million years, Phobos crashes into us. It's spiraling inward, just like it is with Mars. A 27-kilometer asteroid slamming into Earth at cosmic speeds. Bigger than the one that killed the dinosaurs. Extinction. Total. Complete. Humanity is wiped out. All because we swapped our moon for 2 space rocks. Finally, Enceladus, Saturn's ice fountain. This tiny moon is only 500 kilometers wide, but it's one of the most active bodies in the solar system. It sprays water, ice, and organic molecules into space through massive geysers at its south pole. These geysers feed Saturn's E-ring. Enceladus is literally creating part of Saturn's rings. It's incredible. And if we swap it in, we get this brilliant white moon, the most reflective object in the solar system. Even though it's small, it shines bright. Nights are dim but not pitch black like with Phobos and Deimos. But Enceladus suffers the same problems as the Martian moons. Too small, weak tides, destabilized Earth, climate chaos, extinction level wobbling. The only upside is the science. Enceladus has a subsurface ocean. As it warms up in Earth orbit, the ice shell melts quickly because it's thin. Within decades, we see liquid water on the surface. We can study that ocean up close. Search for life. And if we find it, if we discover living organisms in Enceladus's ocean, it changes everything. We prove life is common. We're not special. We're just one example among countless others. So here's the truth. Our moon is perfect. Not too big, not too small. It stabilizes our climate, drives our tides, lights our nights. Swapping it out would be catastrophic no matter which moon we choose. Too big and the tides destroy us. Too small and Earth wobbles into oblivion. Our moon is the Goldilocks moon, and we should be grateful for it. Because without it, life on Earth might never have evolved at all. And that's the real story. Not what happens if we swap our moon, but why we're so incredibly lucky to have the one we do.